we did, actually. It's the max-min existence theorem. They call it the extreme value theorem. It's one of the 5 theorems you have to know. I'm sure you've forgotten intermediate value, but we'll hit on that later when it pertains. So in the meantime, we'll still do this. Somebody said the function must be continuous on a closed interval. You might have to state the theorem in the free response questions. I've seen it happen. You have to put the conditions in, and the closed interval is from A to B. Then what must be true? If you have a continuous function on a closed interval, Brian, what can you guarantee? You can guarantee it. It's an absolute. No. The function will achieve both a maximum and minimum value. It must contain both a max and min. The problem is if I don't have a closed interval, or I don't have a continuous function, and, not an or. Now we're looking for the value, Alexi, of the function on that interval. And it's just, you just have to make sure you have that. If you don't have that, then we're going to have to graph some things. These are global. If they don't tell you, assume always global. So the book has a fault in it because they ask for extreme values. They're looking for all of them, local and global, when they say that. But on the exam, if they ask for an extreme value, they're talking about the globals usually. Okay. Where will the max and min values occur? Where are the critical points? The derivative has to be 0. The derivative might be what? Non-existent or undefined. These, by the way, are your critical points. Okay? And endpoints. They are not considered critical points. It's where the derivative is going to be a boundary for the derivative. No, does not exist. Oh, those are critical points. And it's understood. When you say CP, everybody knows that's what that means. Okay? Then, how do you know if you have a max or min at those critical points or endpoints? Yeah, you just evaluate them. I'm going to say at the above points. You just evaluate the function. So the only calculus there is right here. That's it. Finding the derivative, setting it equal to 0, or finding out where it doesn't exist. The rest is just kind of common sense kind of things. And you may need to use your graphing calculator, even though the book does not say you need it. You may still need it. I used to have one. Okay, so what are the steps? If you want to use this theorem, and I like this, when I run into it on the exam, I say, oh, I have a continuous function. It's a closed interval. It says it's furthest to the left or whatever. I go, oh, it's the max-min existence theorem. All I have to do is evaluate my function at the endpoints that anybody can do, or then find where the derivative is 0 and evaluate my function there. So what are the steps? So the first thing you need to look for is the function continuous, and is it on a closed interval? So even if you don't write this down, and yesterday I forgot to put the things up online, but I put them up online. You can print them out in color. Okay, you got to have a continuous function on a closed interval. That's the first thing. If I don't have that, then I can't use the theorem. But if I do have that, then what are we going to do? Find what? Continuous. Continuous. Sorry, sometimes I'll write too fast. On a closed interval. So then you're going to find what? The derivative. And look where what? F prime of x equals 0, or does to check your domain. They have some nice examples in the book. They're not so easy to read either. Might have been worth our while doing one of them. Okay, so first you make sure you have a continuous function, closed interval. Look for your derivative, set it equal to 0. Find out where it doesn't exist, and then do what's the last thing? Evaluate f of x at these points. And don't forget the endpoints. So it's exactly what I said yesterday, but summarized. And 4.1 through 4.3 is kind of blended. So I'm going to give you a little bit out of the next section that'll make things a lot easier. They don't really say it, but we'll do it. Okay, can I change the slide? Well, continue. You almost always have to have a continuous function. It's a closed interval. I just say, oh, I can use this there. And then you look for your derivative. It's a theorem. This is a theorem that you may use. How do you use it? This is the process. Yes. Then you're going to have to graph it. Or you have to know what it looks like. So let's look at an example of that right now. I'm glad you brought that up. Because what about y equals x squared? Okay, Casey? From negative infinity to infinity. Now, I don't even need to graph it, and I hope you don't need to graph this either. Declan? Jack? Girls? Shh. What if you don't have a closed interval? First off, there's no guarantee you get both a max min, or either one of any of them. But what does this look like? Right. But you know what that looks like. Is there a maximum value of your parabola? No, not on the open interval. Okay, girls? So there's no max. It doesn't mean you can't have a max or can't have a minimum. Is there a minimum? Yes. Minimum occurs. Now be careful. Yes, but you make sure you are clear about that at x equals 0. That's not the question. And the value is the question. What's the value here? Turns out it's the same as the x coordinate. The value, the y coordinate. Let's write that in there. So this is one where I don't have to graph it. I already know the answer. But if it's some weird functions that you don't know what they look like, and we're going to do one, yeah, then you have to graph it. But not on the exam, no. You'll have to do the work. No, because everything's AP. Much AP as I can get. Pretty much you will only see AP questions now on assessments. Okay. So if it's an open interval, it makes me have some difficulty. So I kind of have to give you a little bit of information from the next section. Okay, how do you find a local maximum value? There's my C. What's true about f of C? It must be greater than all the other y values in the neighborhood. Does that make sense? Because it could have done this. This is a local max. That's a local max. This is the best one in this neighborhood. That's the best one in that neighborhood. This obviously is also global, though, the way I drew it. The locals are just in their neighborhood. I have the best Christmas lights in my neighborhood. That's because I'm the only one that has Christmas lights. Mine are Christmas lights. Yeah, you have to look in the neighborhood. So you can look in your neighborhood. Who has the best lights in your neighborhood? Do you have the best lights in the city of Minneapolis? Probably not. You probably don't remember the place down on in Chan with all the lights. Do you remember that? But they're not doing it anymore, are they? Oh. They had everything. do that. Okay, shh. Okay, so we have work time today. How do you know you have a local minimum? Hey, you guys, I'm drawing pictures here for a reason. F of C is less than F of X. Now, that's the new thing right there. What conditions must be true? Okay, guys in the back? Back? What must be true to have a local extreme value? It's not enough to say the derivative is 0. Okay, James? Here the derivative is 0. Right there. Is that a max or min? So look at your pictures here. What has to be true about the derivative to make sure you have a maximum or minimum? They have to change sign. It has to go from positive to negative or negative to positive. F of X is any value in its neighborhood. C is the one you think is going to give you the biggest value or smallest, whatever it is. Okay, this is the next section. But you can't really do the homework unless you know that you're looking for a change in sign in the derivative. I don't care if it was undefined or 0. It makes no difference. It just has to change sign. In the next section, we'll determine by the change of sign if it's a max or min. And you could figure that out. I never memorize it. I just look at the picture. Okay, what's a critical point? F prime of X is what? 0, or F prime of X is undefined. Yep, I want to make sure you got it. So how do you find, now you guys, this is not necessarily on a closed interval. How do you find extreme values for any interval? You always look for where F prime changes sign. Because you will have some. And I have pictures of the homework. Because my guess is some of you didn't bring your books. You need? It is a small book, but it's not the little book. It's this book. Not compared to, yes, not compared to the other books. What? Yes, you should bring your books. Because I don't think it's going to take that long to do 4-2 tomorrow. Okay, you guys, let's do a problem. Then let's look at some homework questions. And actually, in the other class, we got through all of day 1 in about 5 minutes. Didn't take long. Okay, this is a problem. You guys, I don't know what number it is, but in the book, it's one of the homework problems. And it actually is from negative infinity to infinity. Okay, so let's do this problem. But we are on endpoints here. And might be one where you might have to look at it to see what it looks like. So I would like to look at the graph of that. Well, let's do the endpoints. So here's x, here's f of x. Now, what if I put in 2 or I put in negative 2? Am I going to get different answers? Alexis, am I going to get different answers? Put your phones away, girls. Okay. Well, let's find f of 2 is equal to e to the minus 2 squared. What is that? That's 1 over e to the 4th, which is about, e is about 3. 3 to the 4th is 81. It's pretty darn little. What's f of negative 2? This is no calculus. This is evaluating your function. I get the same thing because the negative 2 is in the parentheses. For me to put it in there, it's kind of squishy. Okay. Well, now those aren't the critical points. Where are you going to find your critical points? They're both 1 over e to the 4th. They're the same. Because it's e to the negative, negative 2 squared. No, order of operations. Okay, guys, this is the homework question, which is different than what I'm doing, slightly. Only slightly. It's positive 4. Okay, ready? Okay, f of x equals this. Declan, what's the derivative? What is the derivative? No. Negative x squared times, Riley, what's it times? Okay, you guys, I want the talking to stop because we're going to do homework problems as soon as this one's done. Now, you guys, you have to say f prime equals that. You can't just write the derivative down. There are 500,000 AP exams. We cannot assume anything. If you don't have it written, it's not there. So we don't know what you're talking about. And I know you can look at me, you can say, but you know what I meant, and you're probably exactly right on that. But that's not the way they're going to grade the exam, so we got to get in good habits now. Then we look where this is undefined. Is that ever undefined? So we look where this is 0. And you really need to show the steps correctly. So first I'm going to look for e to the minus x squared. Is that ever 0? No. I took the derivative. Or negative 2x has to be 0. Now this is a much simpler example than what they have on the exam. Oh yeah, because this one's easy. What? This is the derivative. It's e to the minus x squared times negative 2x. That's different. So what's, okay guys, what's x equal to? 0. Put up here in your little chart, what's f of 0? It's 1. It's e to the 0, which is 1. Okay, now we have the answers. This is what? Max or min? Now, it may bother you, but the minimum occurs at both places, but that's the minimum value. Doesn't matter that it occurs more than once. What's the minimum value of the sine function? It doesn't matter that it occurs many places. Okay, shh. Hey, don't do that. Alexis, sit still, please. Alexis, what's the maximum of the sine function? It's always one. I don't care where it is. And what's negative 1? Okay, guys, Declan, where's the minimum value of the sine function? Or what is it? Excuse me. Well, it's a problem. I'm just saying that this has the same minimum value multiple times. It's the same maximum value multiple times. We're not asking where. We're asking what is. If I can get that through, because that's the biggest thing right now, you're going to answer the question with the where, not the what. Now, what does this thing look like? Do you guys know what this looks like? Let's do the homework problem. The homework goes from negative infinity to infinity. Okay, guys in the back? I don't know exactly what it looks like here, but I just know it's always going to go down. Is it ever going to hit 0? So if I look at negative infinity to infinity, there is no minimum. Can't do it. Only ones where you can do it is when you have a closed interval and a continuous function. What's the max? 1. Example 2 and 3 are going from negative infinity to infinity. If you want practice with derivatives, I thought we'd just do the problems in the homework. Okay. You understand how to use the theorem? How do you not use the theorem? That's going to be one of the questions. So let's look at the homework. I'm already ready for you. We can do those examples. They're a little bit harder to do, but now notice that I'll go to infinity. So we can, but what about the homework? What about this? I disagree with their answer on 3. It says find the extreme values and where they occur. So this is x equal to 0. The max is equal to what? 2. What's the minimum? At x equals 2 and negative 2, the minimum is what? 0. Don't worry about the local, global. It's not what it's asking. Hey, Jack. Is that okay? Now on 3, Jack, give me a max here at x equals 0. Max of 5, and that's true. But they don't include that for a minimum, and I've looked in the book, and I can't tell that that's not an open circle or closed. So I say when x is equal to 2, y is equal to 0. That's the minimum. But that's what all they say here. So I think they're wrong, unless I just need better glasses. Is it an open circle? Okay. So I just looked at the thing. So we'll take that out. So that's supposed to be an open circle, so there's no minimum. There we go. Okay, those are first 2 questions in your homework. Jack, put your phone away, please. How about that one? This one's a lot clearer. This is number 7, no minimum. Hey, you remember doing this last year in pre-calc? Yeah. And the maximum value is f of c. Doesn't matter if the derivative doesn't exist there. It still has a maximum value. Okay, use your intuition and your logic. Okay, Riley, Brian, put your phone away. But you're not using the calculator. That's the only problem. Okay. Hey, yesterday we did this one. I hope we didn't assign 15 because I think it's a silly question. Hey, guys, why is 15 a waste of time? Guys, one at a time. Tyler. Right. Well, you have to check your interval, but most likely it's 1 or negative 1, so it's kind of silly to take a derivative. You know what it is. But what about which one? What about 17? Oh, I think I read that wrong. Okay, Jack, do you need a new seat? I need you quiet. You're taking a test next door for 1 minute. What about 17? I think I read it wrong in the last class. I did 2/3, but it works the same. Is that a 2/5? Okay. Now, can I apply the max-min existence theorem here? Sorry. Okay, guys, we're getting your homework done. I can't because it's not a closed interval. But can we still look for max and mins? Yeah. Okay, Declan, do you guys need different seats over here? Then I expect you to be quiet. Okay, Lexi, how am I going to do this? How? I don't know what it looks like. What? Can you do a negative number? Can you take a 5th root of a negative number? What's the 5th root of negative 32? It's negative 2. Okay, so I know, I thought about that too. Not only that, it's squared. Now, this is a root function, and all root functions look alike. And the problem with this, you're still going to have to look at the picture. It's going to look like this on this side, and it's going to look like that on that side. The question is, will I get a maxima at one of those points? If this one ends up being the maximum, then it's open. If it ends up with negative 3 being the maximum, then it does have a maximum because this is an open circle here. This is a closed circle. Because I know what a root function looks like. So I said you might need to use your graphing calculator, Casey. It would be something you would know or it'd be a closed interval. If it was what? A square root? No, you wouldn't have it on the other side. Okay. Let's do this one and we'll do the back ones. Okay? Okay, guys, what's y prime? It's 2/5. Okay, guys in the back. The negative 3/5. Yes. I don't like that. So it's 2 over 5, and it's the 5th root of x to the 3rd. Where is there a problem? There's only a problem one place. X can't be what? Why? What's happening at 0? What's true about the tangent line? It's vertical. Okay, so you find that f of 0 is 0. And because this is squared, I know it's always positive, so that's going to be the minimum. I'm not using the maximum existence theorem. I'm looking at the graph. Now, evaluate f of negative 3 and f of 1. Let's do f of 1 first because that's easier. What's f of 1? It's 1 to the 2/5, which is 1. What about f of negative 3? What's 1 to any power? Okay. Okay, guys. This is going to be really 9 to the 1/5 power. Is that bigger than 1? James? What's 1 to the 5th? 1. That's bigger than 1, so the 5th root of 9 is going to be bigger than 1. I mean, you could put on your calculator and see. But this is bigger than 1. Therefore, this does give me my max. Here's the maximum value. Had it been the other way around with this open and that closed, then there wouldn't have been a max. If it's not a closed interval, that's the problem. So let's do this problem. This is no what? It's asking for maximums. Yeah, let's put them in. You guys know what that looks like? Product rule. So let's find the derivative. Because you guys, the hard part here is not calculus. It's the algebra. So it's x to the 2/3 times 2x, right? Plus x squared minus 4 to the times the derivative of x to the 2/3. 2/3 negative 1/3. So it's x to the 2/3 times 2x. And let's see, this is plus x squared minus 4 times 2, and this is over 3 cube root of x. Well, there's clearly, Casey, can you settle down please? Yeah, this goes in the denominator. This too? Still there. Okay, where is there a problem right now? Because it's the first one times the derivative of x squared minus 4, which is 2x. Product rule. Then we didn't even have to do the chain rule. No, product rule. X squared minus 4 times the derivative of that. Always, no. No, I'm not. Just couldn't resist. Okay, what's the easiest critical value to find? 0. Yes, he is. Okay. You guys are so weird. Okay, what's f of 0? You guys? What's f of 0? 0. Okay, now the hard part is setting this equal to 0. So 0 equals 2x. Can we combine those? What is that? That's x to the 5/3, isn't it? Right there. I'm just multiplying it. I'm multiplying this. Because this is 3/3 plus 2/3 is 5/3. Plus, I don't want to set this equal to 0 yet. I mean, now I want to do it. Okay? Jack? Not now. And let's subtract this one. It doesn't matter. I didn't leave myself any space. Whoops, over the cube root of x. Okay, what are we going to do with these? We're going to cross what? Multiply. I'm just going to move on down the board. Well, actually, I might go over to the side. Okay, multiplying these, I get a negative 6. There are a couple of ways we can do this. X to the 5/3 times x to the 1/3. Not like that. Equals 2x squared minus 8. Right. Did I do it right? Oh, yeah, I'm right. I just combined those. X to the 2/3 times x to the first is x to the 5/3. Now, what's x to the 5/3 times x to the 1/3? It's the 6/3, right? Equals 2x squared minus 8. Little tiny steps. What is x to the 2/3? What is this? Because what do you do with exponents? We add them. So it's x squared equals 2x squared minus 8. Now what are you going to do? I could do that. Why don't we just solve? Why don't we just subtract 2x squared from both sides? Now what I've done is transform that really ugly looking equation into something where I probably have to guess what makes that true. Now, it may not work in the original. You've got to always check it. So this is negative 8x squared equals negative 8. Now, do I really have to do any more work, or can you tell me what x is? X is equal to 1 or negative 1. I can divide by negative 8, so I get x squared equals 1. If I had x squared equal to negative 1, what would happen? You couldn't do it. It is plus or minus. So now what do we have to do? Evaluate my function at 1 and negative 1. Is it any different? Hey, guys? Is it any different? What is f of 1? It's 1 to the 2/3, but that's 1. And it's 1 minus 4. What's f of negative 1? Well, the cube root of negative 1 is negative 1, but I'm going to square it. Guess what? It's the same thing. My guess is that's the maximum value and that's the minimum value, but how am I really going to know? Yes, you could have simplified it right away. That would have been a lot easier, but we didn't. I have to graph that. I don't know what it looks like. Well, I didn't want to do this problem. Then we did it. The next one is probably more relevant. Okay, so let's take a look at that. And it's from negative infinity to infinity. So I'm going to clear that out. Sometimes I don't like the new operating system. So it's x to the 2/3. Now, if I were graphing this on the graphing calculator, I would not simplify that because I might do it wrong. I have a better chance of doing it this way. Still going to do it wrong. Okay, I think I copied it right, and I like to zoom it forth. Oh. Is there a global max? Okay, you guys, listen carefully, Jack. You can't tell unless you graph if it's an open interval. True, I do have relative min, and that's a relative max, but I don't know that there's no global max because I don't know what it looks like. So you have to graph it. So if they were to ask you that, you'd have to be on the graphing calculator part of the exam. So I can tell you, it's going to be a closed interval. You still have to look at it, or you have to know what it looks like. Even I didn't know what it looked like. You can find local ones, not the absolute. There is an absolute minimum, but the only way I can tell is because of my graph. Does it ever turn around again? Doesn't look like it. We will do more tests on that coming up. Not without a graph. Not if it's not a closed interval. Remember, the max-min existence theorem, guys, in the back row, only applies. You can only get the guarantee if you have a continuous function on a closed interval. Just the way it is. So if you don't have a closed interval, there's no way to guarantee it. That doesn't mean to say it's not going to happen. You have to graph it. Only way to know. So when you get, if you look at the assignment, and you look at any of these with open intervals, and this one's pretty typical, x squared e to the x, I've seen many years over and over, and would not hurt to do that one, but Noah? Oh. So when you have open intervals, the only way you can do 18 is to look at the graph. You got to look at the graph. Now, on 19 through 30, how are you going to know if you have a max or minimum? You would probably have to graph it. You can substitute it, but unless you know what the function looks like, and I know what 19, 21, 20, and 22 look like, but do you know what 23 and 24 look like? And 25? Probably not. That's the problem. That's why I don't like this, to tell you the truth. Because we have another test and we haven't done it. If you want to look at the first derivative and make sure it changes sign, then you'll know if it has a relative max or min. But we really haven't done that yet.